Hello students, yesterday we were discussing rounding of numbers. Okay, so we'll continue that one. Yesterday there was some interruption in the video, so I will continue from there only. In addition and subtraction, okay, whenever you are adding, see three physical quantities. So this physical quantity has one decimal place, this has three decimal places, and this has two. Okay, if you add it, final answer is this one. But see, the final answer must contain as many decimal places as there are in the number with the least decimal places here. In this number, which is having the least decimal, so this number, okay, it has 0.2 only, so one decimal place. So final result also must contain least decimal places. Means you have to round off this number, okay, to one decimal place. We need only one decimal place, means we have to remove 9. If you remove this 9, this 3 will become 4, because 9 is more than 5, so it will become 4. Okay, so 1974.4 here. Next, rounding off some numbers. Okay, see, whatever number is to be dropped is less than 5, then preceding number is remain unchanged here. See, 5.94 is there. We want only 5.9, means you have to remove 4, but this 4 is less than 5, so therefore without changing this 9 we can write this one here. Okay, see, we have 5.94, but we want only one decimal place. So one decimal point if you want, means 5.94 we have to remove. 4 is less than 5, so remove without any change this 5.9. Okay, similarly, if you want to round off the two significant figures, here it is having 1, 2, 3, 4 significant figures are there. So 4 significant figures are there, we want only 2, means 1, 2 only should be there here. So what I have to remove? I have to remove this 3. Okay, so 3 is less than 5, so remove this 3 and 8 as it is here. We don't have to see this 8, we have to see what is the number to be removed, 3. So therefore 3, if you remove it, since it is less than 5, okay, we write like this here, 0.0070 here. Next, suppose the digit to be dropped is more than 5, then the preceding digit is increased by 1. Okay, see, in this 2.746, round off to 3SF. Okay, we are having 2.746, round off to 3SF. 3SF means 3 digits we want, 1, 2, 3. I want 2.74. So what I have to drop? I have to drop 6. So the digit to be dropped is more than 5. See here, the digit to be dropped, I have to drop 6, but it is more than 5. So what I will do? The preceding digit is increased by 1. So we are increasing the preceding digit. The preceding digit is 4. Increase this one by 1, means it will become 5. Okay, so the digit to be dropped is more than 5. The preceding digit is increased by 1, so it will become 2.75. So I have written here. Okay, next see here, in this example we are having 1, 2, 3, 4, 5 significant figures are there. We want only 4 significant figures, means we want 4906, but 8 is there. 8 is more than 5, so we have to increase the preceding number by 1. So if you are dropping 8, increase the preceding number by 1, so this will become 7. So here we have done here. Okay, so therefore remember, the number to be dropped is more than 5, the preceding digit is increased by 1. Okay, next, second one, suppose the digit to be dropped is exactly 5. Whatever digit we are dropping is exactly 5. In the previous cases, see, the digit to be dropped is more than 5. Before that, the digit to be dropped is less than 5. Okay, but the digit to be dropped is exactly 5. Whatever we have to drop is exactly 5. Okay, and it is followed by zeros, then the preceding number or the preceding digit is increased by 1 if it is odd, and remains the same if it is even. See, you will understand if you see this example here. Okay, see this example. In this example here we have 8.645. I want 3SF, means I want 1, 2, 3. I want these 3 digits, 8.64. So what I have to drop? 5 I have to drop. So the digit to be dropped is exactly 5. If the digit to be dropped is exactly 5, the preceding digit is increased by 1 if it is odd. If it is remains the same if it is even. See, the preceding number is even, so this remains the same, 8.64. Remember this. I am repeating. Okay. Digit to be dropped is exactly 5. The preceding number remains the same if it is even. What is the preceding number? Preceding to 5. What is the number before 5? The number before 5 is 4, even number. So this will remain same. If it is a preceding number is even, it remains the same, 8.64. Now, if the number to be dropped is exactly 5, see here in this case, okay, then the preceding number is odd, it is increased by 1, 8.64. Okay, I have to drop 5. So if I want to drop 5, I have to see the preceding number. The preceding number is here odd. So if it is odd, its number, digit is increased by 1. So 8.64. So remember this point. This is important. If the number to be dropped exactly 5, preceding number is increased by 1 if it is odd. If it is even, remains the same. Next, 8500 joules. Okay, this is one number. We have to round off to 1 SF. Here how many SF are there? Here 1, 2. Okay, we have 2 SF is there. Okay, if there is no decimal point, final zeros are not important. That is what the rule. That is the rule we have studied. Okay, see what are the rules? You know, previously we have studied the rules. No decimal point, final zeros are not important. Only 1, 2. Now they want only one significant figure here. So this is written as 8 into 10 raised to 3. So 8,000 means it is 8,000. Okay, so number to be dropped is here 5. Okay, so number to be dropped is 5. The preceding number is even, it remains the same. So therefore it will be 8,000. So we written here 8,000. Okay, similarly here this is I want 1, 2, 3, 4 significant figures are there. We want only 2 significant figures. Okay, so 2 significant figures means we want 8 and 4 here. So 8457 is there. It is rounded up to 8.5 into 10 raised to 3. Okay, so this way we can write find the significant figures. Okay, so this you have to learn the rules before you practice the numericals. Okay, so next we have dimensions and dimensional analysis. What is dimension and dimensional analysis? Dimension means the power to which a given physical quantity is raised. Okay, more you will understand when we do the numericals here. The power to which a given physical quantity is raised is called dimension. Dimensional formula means relation between the fundamental physical quantities and derived physical quantities. Okay, so these two definitions you will understand when we do the numericals. Okay, let's see some dimensional formula of some physical quantities. We are having some physical quantities like displacement, distance, length. All are having the unit meter. Okay, wherever meter is a unit, you have to write the dimensional formula L. Okay, if meter is a unit, the dimensional formula for meter is L. Next, for mass, it is kg. So wherever you find kg as a unit, you have to write here mass m. You have to write here. Okay, time is measured in second. So for second, dimensional formula is T. And temperature is measured in Kelvin. So it is K. Current is measured in ampere. Its dimensional formula is A. So students, remember, it is length, mass and time. For these two, it is easy to remember. Length, dimensional formula L, mass is m, time is T. But temperature, it is Kelvin. So K. Current, it is ampere. So we write here A. You have to remember the unit and corresponding dimensional formula. Okay. Similarly, now coming to this other physical quantities. Okay, see, in other physical quantities we have, suppose velocity is there. Okay, velocity dimensional formula, velocity formula is displacement upon time. Displacement is measured in meter. So I just now said wherever meter is there, meter means length. So we have to write here L. Displacement is measured in meter. Meter is nothing but length only. So we write here L. Time is measured in second. Time is time dimensional formula is T. So I have written here T. So L upon T. So LT inverse. By heart, this dimensional formula V is equal to LT inverse. Acceleration is given by velocity upon time. So velocity dimensional formula, just now we have written LT inverse. LT inverse upon T. So that LT power minus 2. Okay. Force is equal to MA. Force formula we know MA. So mass is m, acceleration just now we have written L T power minus 2, so ml T power minus 2. Work done formula force into displacement. Force formula ma and displacement is s. Okay, so this mass dimensional formula is m, acceleration dimensional formula L T power minus 2, displacement is L, so L into L square, m L square T power minus 2. Remember, work is nothing but energy, any form of energy, whether it is electric energy, potential energy, kinetic energy, heat energy, you have to remember one formula. Okay, for all types of energy and work, this is a dimensional formula. If they ask kinetic energy dimensional formula, write m L square T power minus 2. So you have to by heart this one. Okay, these dimensional formula, these four whatever I have written, they are fundamental. You must remember. Okay, you have to by heart this formula. Velocity L T power minus 1, acceleration L T power minus 2, force ml T power minus 2, work ml square T power minus 2. Now we have to write the dimensional formula of some physical quantities. See, I am having dimensional formula for I want gravitational constant G. See, in this formula F equal G m1 m2 by r square. We have this formula. So F equal G m1 m2 by r square. From this find the G formula. Make G as an object. Take cross multiplication. You get F r square upon m1 m2. F is force. So we have written dimensional formula. R is a distance. Distance is measured in meter. Meter means length. So L square I have written here. M is mass. So mass I have written here. For this also again mass M I have written. This mass and this mass gets cancelled. So cancel this and this. Take this M to numerator. M raised to minus 1. L into L square. L cube and T power minus 2. Okay. Similarly, pressure. Pressure dimensional formula. Pressure is equal to force upon area. You must know this formula. Okay. This we have come across in lower class. Force upon area. Force dimensional formula is MA. Area is measured in L square. Okay. Length into length. So M dimensional formula M I have written. A is L T power minus 2 L square. Simplify. You will get this one here. Density is mass upon volume. Mass is m, volume is L cube. So we get ml raised to minus 3. Angle formula. See here, angle is this one here. Okay, this is L, this is R and theta. Theta is equal to L upon R. That is why I have written arc. This is L is nothing but here arc. Arc length. Arc length upon radius. Arc length is L. Radius also length. So L upon L. No dimensional formula. Okay. Next, electric charge. In the lower class we have studied. Current is defined as I is equal to Q by T. From this, Q is equal to IT. Remember this formula. Current is equal to Q by T. In the 10th standard we have studied. So Q is equal to IT. I means current. Current is measured in ampere. So A. Time is T. So T we have written here. Potential is work done upon charge. This also we did in 10th standard. Work means ml square T power minus 2. Previously we did. Charge is AT. We have written. So right here simplify. Resistance, Ohm's law we have studied in 10th standard. R is equal to V upon I. V formula just now we have done. So write that formula. I formula, I is measured in ampere. So A, simplify you will get this. Okay. So these are some of the dimensional formulae. Now, what are the uses of dimensional analysis? Uses of dimension. To check the correctness of given equation. To derive the correct relationship between different physical quantities. To convert one system into another system. To find dimensions of a given physical quantity. More details related to this in the next class we do. So that's all for today. Whatever formulae I have shown, all these things should be in your notes. Have a good day.